Hello students, we are discussing class 10 General Science chapter 2 Acids, Bases and Salts. So in earlier video we have learned about the introduction of acid and bases. So in this video we will learn about the chemical properties of acids and bases. Dear students, acids and bases are available in the laboratory. So here we are asked to do an activity. So in this video we are just trying to say what are the properties of acid and base by testing with the indicator. We are taking several indicators and the properties of acid and base by using that indicators. So you are asked to collect some acids and bases from your science laboratory. So dear students, it is not possible to collect the acid and bases from laboratory, but what color will be changes from acid and bases, or what properties will be show, I will just try to explain you. Hydrochloric acids, sulfuric acids, nitric acids, acetic acids, these are the acids which are available in the laboratory. Sodium hydroxides are base. Calcium hydroxide, it is also a base. Potassium hydroxides, it is also a base. Magnesium hydroxides and ammonium hydroxides, these are all base. The OH group which are present, this OH group, they are bases. So now dear students, if we take acids, hydrochloric acids, sulfuric acids or nitric acids or acetic acids, a drop, and put in that drop of hydrochloric acids in the red litmus paper, then it is found that the color of litmus paper does not change. But if the hydrochloric acid is tested with blue litmus paper, then it is found that the blue litmus paper actually become red. Become red in color. Similarly, with sulfuric acids or nitric acids and also acetic acids, when we tested the red litmus paper, then the color of red litmus paper does not change. It is remain as it is. But when we test it with blue litmus paper, then the color will become red. Okay. If we test with base sodium hydroxides or calcium hydroxides or maybe potassium hydroxides, then on testing the red litmus paper, the color of red litmus paper turn to blue in color. But when we check with sodium hydroxides or potassium hydroxides or magnesium hydroxides, the blue litmus paper does not change. Similarly, when we check with another indicator, phenolphthalein, then by taking a test tube or a conical flask, and in this conical flask we are taking acids, this is your acids and bases, in two conical flux. So when we add phenolphthalein in acids, then the color does not change. So hydrochloric acid, when added to the phenolphthalein, the color does not changes. But when we add it to the bases, then the color of the bases will become pink. Okay, so I have written here, when we added acids in phenolphthalein, then the color of acid does not changes. But when we added base, when we add phenolphthalein in bases, then the color will become pink. By using another methyl orange in acids such as hydrochloric acids or sulfuric acids or nitric acids, then it is found that the color of acids, when we added methyl orange, then it will become red in color. So when we add methyl orange here in acid, then the acid solution become red in color. And when we added methyl orange in base solution, then the base solution will become orange in color. Okay, this is written here. When we added acids in acids, when we added methyl orange, whatever the acid may be, in hydrochloric or sulfuric acids or nitric acids, that is found that the color of the acids will become red by adding methyl orange. And when we added bases, uh, methyl orange in base, then the color will become yellow. So actually, this indicator, litmus paper, or it may be methyl orange, or it may be phenolphthalein, they actually indicates us or tell us whether the substances are acids or basic, okay, by changing in colors, isn't it? So litmus paper changes the color. Red litmus paper changes to blue when base is added. That means in presence of base, base turn blue, red litmus blue, and acid turn blue litmus red. Similarly, phenolphthalein when added to acids, no color will changes, colorless. But when we add methyl orange to the acids, then the acids will become, acid solution become red in color. In bases, when we added phenolphthalein, then base solution will become pink in color, wasn't it? But when we added methyl orange in bases, then that base solution will become yellow in color. So these indicators will changes the color of acid and bases, thereby indicating the substances are either acids or bases. So dear students, apart from this, another activity is given. You have to take some onions and chop into finely. After that, you have to uh, pack in a plastic bag along with some cloth, okay, strip of clean cloth, and wrap it. The bag should be tight and kept it in the fridge or refrigerator overnight. Then after that, we have to remove the onion chop and take the cloth strip, okay. Then you will find that the cloth strip will be smell, give the smell of onion. Okay, now with the cloth strip we have to check the substance, that means test the substance whether acids or bases. Okay, so when we added acid in the, cloth strip which has been pack the chop of onion. Then after adding the acids, actually the color of the the smell of the onion does not goes, or it will remain as. But when we added base to the cloth strip, then the smell of the onion will be vanished. Similarly, when we test with other indicators are there, such as clove or vanilla, then also it is found that in vanilla, when we acid will add it, then the smell of vanilla does not changes or remain as it is. But when we added bases, sodium hydroxides or bases, then it is found that the smell of vanilla will be vanished. Similarly, in case of the clove, when we added hydrochloric acids or any acids, then the smell of clove will be remain as it is. But when we added bases, sodium hydroxides, then the smell of the clove will be vanished. So from here we have understand that this onion, vanilla or the clove, they are used as an indicator which indicates, that means change the smell of the substances by adding on acids or bases. So those type of indicator which is changes the smell are known as olfactory indicator. Okay, so in the next video we will learn about the reaction of acids with metal and others. So that's all for today. Thank you.